आज हम लोग 12th क्लास के फर्स्ट चैप्टर को स्टार्ट करने जा रहे हैं। फर्स्ट चैप्टर का नाम है रिलेशन एंड फंक्शन। रिलेशन एंड फंक्शन। तो जैसा कि आप सबको मालूम है कि रिलेशन फंक्शन 11th क्लास में ही इंट्रोड्यूस हो चुका है, तो हम थोड़ा रिकॉल कर लेते हैं। सबसे पहले हम स्टार्ट करते हैं जो फर्स्ट टॉपिक है रिलेशन फंक्शन से रिलेटेड, दैट इज़ कार्टेशियन प्रोडक्ट ऑफ टू सेट्स। अगर हमारे पास दो सेट्स हैं, सेट ए एंड सेट बी, सेट ए के पास एलिमेंट्स 1 2 है, सेट बी के पास एलिमेंट्स ए बी सी है, तो हमारे पास कार्टेशियन प्रोडक्ट ऑफ ए एंड बी जो डिफाइन होता है, दैट इज़ सेट ऑफ ऑल पॉसिबल ऑर्डर्ड पेयर्स such that first element belongs to set A and the second element belongs to set B. So यहाँ पर ordered pairs की बात होती है। इसके बाद यहाँ पर बात हो रही है set of all possible ordered pairs such that first element belongs to set A and the second element belongs to set B. यहाँ पर ही हम लोग स्टार्ट करते हैं सबसेट। व्हाट इज सबसेट? सबसेट ऑफ एनी सेट दैट इज दैट कंटेन्स वन और मोर एलिमेंट्स ऑफ दैट सेट। नाउ वी प्रोसीड फर्दर। एनी सबसेट, रिमेंबर, एनी सबसेट ऑफ कार्टेशियन प्रोडक्ट ऑफ ए एंड बी इज अ रिलेशन from set A to set B. So जैसा कि हम लोग जानते हैं कि कार्टेशियन प्रोडक्ट ऑफ टू सेट्स इज नॉट कम्यूटेटिव, दैट इज कार्टेशियन प्रोडक्ट ऑफ ए एंड बी इज नॉट सेम एज कार्टेशियन प्रोडक्ट ऑफ बी एंड ए. सो any subset is of Cartesian product of A and B is a relation from set A to set B. If we take a subset of Cartesian product of B and A, that will be a relation from B to A. Now, if there is a set which is a subset of Cartesian product of A and A, then this R is said to be a relation from A to A, or R is a relation in A. So we have recalled all the relation and function, concept of relation and function. Now, how many elements are possible in Cartesian product of two sets? So Cartesian product of two sets, you can see here the number of elements in set A is 2, number of elements in set B is 3. So number of elements in Cartesian product of A and B will be, can you tell me? Just give the answer. It is the formula Na into Nb, that is 2 into 3, that is 6. Now what is the possible number of relations from set A to set B? As per definition, any subset is a relation from A to B. So how many relations are possible from set A to set B? Just pause the video and think. So come back and let us find out the number of subsets. So number of subsets of a set A containing, if the number of elements in set A is n, the number of subsets is 2 raised to the power n. Hence, if you have number of elements in Cartesian product of A and B is n, number of relations from A to B is 2 raised to the power n. In this case of example, number of relations possible from A to B is 2 raised to the power 6. So in this way we find out the relation. Now in 12th class we have to mainly focus on relation in a particular set, relation in a given set. So we are focusing this type of relation, and as we know, if we are going to find out the subset of a set, so empty set is a subset of all sets, and also every set is a subset of itself. So empty set is called empty relation. Our relation from A to A is empty relation, and second is universal relation. That is the Cartesian product of set A and A itself is called universal relation. Very interesting example is there in NCERT. It says we have a set A. Set A is the set of students of a boys' school. Set of students of a boys' school. You can refer NCERT. Now, a relation R is defined as it contains all possible ordered pairs A and B, where R is defined on set A or in set A, such that A is a sister of B. The first element is a sister of second element. So, can you guess how many elements are present in this relation? You must think on. So, you can find out the number of elements in this set is 5. So, it is an empty relation because in boys' school there is no girl. So, it is not possible that one a student is sister of another student. So now let us take another type of example, that is example of universal set. So universal set, now in the same set, on the set of students of a boys' school, if we define another relation, let it be R1, if we define another relation R2, which contains ordered pair AB, such that difference of height of A and B is less than 2 meter. So again think on it, how many elements are in this set and which elements should be in this set. So did you get an answer? You have all the elements, all the ordered pairs of students which is present in Cartesian product of A and A are related with each other under the relation R2. So it is universal set, every element is present. Why? Because the tallest person has a height of maximum, I don't know, but it should be less than 2 meter. And the tiniest person or tiniest student in a school or school going student must be more than 50 centimeter. So the difference must be less than 150 centimeter. So all the pair of students which are present in the school are related to each other as per this relation. Now come back to some more interesting relations which have a maximum use in mathematics and several fields. So the one of such relation is equivalence relation, but before going to equivalence relation we need to understand reflexive relation. So what is reflexive relation, what is symmetric relation, and what is transitive relation? We have to understand these relations first. So let us first take reflexive relation. So we have to take a relation R in set A. That means R is a relation from set A to set A is said to be reflexive when if for all elements in set A we have Cartesian product, the ordered pair A comma A belongs to the relation R. If every element of the set A is related to itself under relation R, then R is reflexive. Otherwise, it is not reflexive. Now, come back to symmetric. So, symmetric, I can tell it as a symmetric relation. Why it is when it is called symmetric relation? It is called conditional. So, what is the condition? It says if ordered pair A comma B belongs to R, if A is related with B, then we must have ordered pair B A related with R, then only R is symmetric. Otherwise, it is not symmetric. So, the condition for symmetric in our symmetric relation is this. So, let us move. As I told you, it is symmetric relation is conditional relation. So, a conditional relation means what? If A comma B belongs to R, then only B comma A needs to be in R. Otherwise, it is not necessary. So, for all A comma B belongs to set A B should be in set A should be element of set A, B should be element of set B. Now come to the third type of relation, that is called transitive. Transitive relation. Transitive relation, a relation R is said to be transitive if A comma B belongs to R and B comma C belongs to R implies A comma C also belongs to R. So the number of condition increases here. If A is related with B and B is related with C, then A must be related with C. Then only a relation R is said to be transitive. Otherwise, it is not transitive for all A comma B comma C belongs to set A. So, finally, a relation R is said to be equivalence relation if it is reflexive, symmetric and transitive, all three. So I think it is written by all of you. The relation is said to be equivalence relation if it is reflexive, symmetric and transitive. Now let us consider some examples. The first example we have here. Let T is the set of all triangles with relation R is given on T by R is given by it contains ordered pair T1 T2 such that T1 is congruent with T2, congruent to T2. So you all have to go through this example and think on it. So what are the steps we needed to prove it is an equivalence relation or not? So first step, we have to prove that it is reflexive. So for reflexive, what is the condition? Every element should be related with each other, with themselves. Every element should be related with themselves. So the triangle is or any triangle which is present in the set of this triangle, we must have its all parts are equal to itself. That means T1 is congruent with T1. So this will give you T1 comma T1 belongs to the relation R, and this is for all T1, all triangles present in the set of triangles T. So it is very clear that every element is related with themselves. Therefore, we are we have a conclusion here: R is reflexive. So this is the first thing. Now come to the second. What is second? Symmetric. Symmetric, what is, how, when a relation is symmetric? It is conditional. What is the condition? If T1 comma T2, the ordered pair T1 T2 is in the relation, then T2 T1 must be in the relation. So if we assume, consider that let T1 comma T2 is in the relation R. So if T1 comma T2, that is ordered pair, is present in the relation R, it must satisfy the condition. So R में present होने का condition क्या है कि T1 जो है वो T2 से congruent होगा. So this is the condition. That means all parts of T1 are same as all parts of T2. So that means we can conclude that all corresponding parts of T2 must be equals to corresponding parts of T1. So if T2 is congruent with T1, we can conclude that T2 comma T1, the ordered pair, belongs to R. That is, T2 is related with T1 under the relation R. So this is true for all such T1 T2 belongs to the set. All such T1 T2 belongs to the set T, set of triangles. If T1 is congruent to T2, T2 must be congruent to T1. So what is the conclusion? Therefore, R is symmetric. This is our conclusion. This is second point we have completed. Now go for transitive. Transitive is also a conditional. What is the condition? In transitive, we have two conditions. So we assume those two conditions. Let T1 comma T2 belongs to R and T2 comma T3 belongs to R. So we have T1 T2 belongs to R. That means it must satisfy the condition to be in the relation R. And what is the condition? Condition is T1 must be congruent to T2. If it is in R, that means it is satisfying the condition. And T2 comma T3 belongs to R means it is also satisfying the condition that T2 is congruent to T3. Now all parts of T1 is corresponding parts of T1 is equals to the corresponding part of T2. All corresponding part of T2 is equal to the corresponding part of T3. So we can conclude all corresponding parts of T1 must be congruent, must be equal to T3. That means T2 is congruent to T3 and T1 is congruent to T2 implies T1 is congruent to T3. So this gives us conclusion that ordered pair T1 T3 belongs to R. And this conclude whenever T1 T is related with T2 and T2 is related with T3, we must have T1 is related with T3. So this implies R is transitive. So in this way, this is the third point. From first, second and third, we can conclude that R is an equivalence relation. First, second and third, R is an equivalence relation because it is reflexive, symmetric and transitive. Any doubt till now? You can ask your doubts. So you can go through other examples of NCERT and find out how to do it. Also, we I will discuss in next slide the difficult questions of exercise 1.1. But before you start exercise 1.1, one more thing I want to introduce, that is called equivalence class. What is equivalence class? Equivalence class, before we start equivalence class, we need to understand what is partition of a set. एक पार्टीशन नाम से ही क्लियर है, टुकड़े। तो एक चीज़ को अगर आप टुकड़ों में बांट देते हैं तो उन दो टुकड़ों में मान लीजिए आपने बांटा, तो उन दो टुकड़ों की खासियत है कि उन दोनों में कोई ऐसा चीज़ नहीं होगा जो पहले टुकड़े में भी होगा और दूसरे टुकड़े में भी होगा, क्योंकि दोनों टुकड़े सेपरेट हो चुके हैं। दो टुकड़ों को आपने बांट दिया, दोनों टुकड़े सेपरेट हो चुके हैं। और अगर उन दो टुकड़ों को आप मिला दें तो पूरा का पूरा पुराना चीज़ मिल जाएगा आपको। फॉर एग्ज़ाम्पल, अगर मैं आपको बताऊं कि सेट ए है, इसके पास 4 एलिमेंट है, 1 2 3 4, और मैंने इसके दो टुकड़े किए, A1 जिसमें मैंने एलिमेंट्स लिए 1 3 और A2 जिसमें मैंने एलिमेंट्स लिए 2 4। आप देख सकते हैं कि यहाँ पर A1 और A2 में कुछ भी कॉमन नहीं है। A1 इंटरसेक्शन A2 इज़ अ नल सेट, इट इज़ अ नल सेट, इट इज़ देयर इज़ नथिंग कॉमन। बट इन दोनों का अगर आप यूनियन करोगे तो आपको सेट ए मिलेगा। तो ऐसे जो ये सेट्स बन रहे हैं, सब डिविजन्स बन रहे हैं, दिस इज़ कॉल्ड पार्टीशन ऑफ सेट ए। A1 A2 आर पार्टीशन ऑफ सेट ए। तो ऐसा मैंने 2 किया है, आप 3 कर सकते हो, 4 कर सकते हो, 1000 कर सकते हो, तो इट डिपेंड्स। लेकिन कंडीशन यही है कि 2 पेयर वाइज आप लोगे सेट, तो उसका इंटरसेक्शन हमेशा एक नल सेट आना चाहिए, और उन सब सेट्स का यूनियन जो है वो वापस आपको पूरा सेट ए देना चाहिए। तो इक्विवेलेंस रिलेशन की एक खासियत है कि वो जिस सेट के ऊपर डिफाइन होता है, इफ आर इज इक्विवेलेंस रिलेशन ऑन सेट ए, देन इट डिवाइड सेट ए इनटू पार्टीशंस, and these partitions are known as equivalence class. For example, on the set of integers, I define a relation. Z is well known, it is set of integers. So we are going to define a relation R on set Z such that it contains ordered pair, such that difference of A and B is divisible by 3. So you can verify that this is an equivalence relation. Let us do this example also. So first we will prove that it is an equivalence relation, and then we go for equivalence classes. What is equivalence class? So फर्स्ट थिंग इज रिफ्लेक्सिव एज यूजुअल। तो रिफ्लेक्सिव प्रूफ करने के लिए हमें क्या करना होगा? हमें देखना होगा कि हर एक इंटीजर खुद के साथ रिलेटेड हो रहा है या नहीं हो रहा है। तो फॉर ऑल इंटीजर ए बिलोंग्स टू द सेट z, we have a minus a modulus is equals to 0, and 0 is divisible by 3. So our conclusion, it is divisible by 3. So our conclusion is ordered pair A comma A belongs to R. For all such integer we have ordered pair A comma A belongs to set R. So conclusion is R is reflexive. Now let us go for the second, that is symmetric. So symmetric, we have to start with assumption. Let we have two integers a and b such that ordered pair AB belongs to R. If it is in R, it will satisfy the condition to be in R. And what is the condition to be in R? The condition to be in R is that the difference of these two must be divisible by 3. So it is divisible by 3. This means the difference of AB should be either plus or minus 3m m should be an integer, r plus minus 3m. So this gives us the difference of b and a must be minus plus 3m, and that gives you the modulus of b minus a must be 3m. So modulus of b minus a is divisible by 3. So now this is the condition for ordered pair b comma a belongs to R. So we started with ordered pair a comma b belongs to R, and we have proven that b comma a belongs to R. So this concludes that R is symmetric. So this is the first thing, reflexive, second thing symmetric. Now come for the third. Third thing is transitive. How to prove transitive? So for proving transitive, we have to start with the two conditions. Let ordered pair a comma b belongs to R, and ordered pair b comma c belongs to R. After taking these two conditions, we know this: if ordered pair ABB is in R, that means difference of AB must be divisible by 3. That because that is the condition to be in R. ये R में तभी होगा जब उसका डिफरेंस जो है वो 3 से डिविजिबल होगा. Is divisible by 3. So this gives you a minus b must be equals to 3 times m plus minus 3 times m. Because it is divisible by m, so difference of a and b must be divisible by m. Also we similarly we have b minus c must be equals to plus minus 3n, where m and n are integers. So after we add these two equations, you can take this as first and this as second. If you add these two equations, equation 1 plus equation 2 will give you a minus b plus b cancelled. A minus c is equals to plus minus 3m plus n. Here, so you can find out that a minus c is divisible by 3. Modulus of a minus c is, so R is transitive. From 1, 2 and 3, that is R is reflexive, symmetric and transitive, therefore it is an equivalence relation. Now consider the set of integers and its 3 sets, a1, a2 and a3. a1 contains some elements like minus 6, minus 3, 0, 3, 6, 9, dot dot dot. So you can find out other elements present in this set. A2 has elements minus 7, minus 4, minus 1, 2, 5, 8, so on. A3 has elements minus 8, minus 5, minus 2, 1, 4, 7, so on. Up from minus infinity to plus infinity. You can find out what another elements are present in this. You see, is there an element common in A1 and A2? No. Is there an element common in A1 and A3? No. Is there an element common in A2 and A3? No. So there is no common element. Among these 3 sets, you have concluded that in A1 intersection A2 is 5, A2 intersection A3 is 5, A3 intersection A1 is 5. पेयर वाइज उनमें से किसी भी 2 सेट का जो इंटरसेक्शन है वो एक नल सेट है, और इन तीनों सेट का यूनियन जो है वो आपको इंटीजर देगा, सेट ऑफ इंटीजर्स. ऐसे सेट की क्या खास बात है? इसमें हर एक एलिमेंट अंडर दिस रिलेशन आर एक दूसरे से रिलेटेड है. व्हाट इज द डिफरेंस ऑफ minus 6 and minus 3? Find out. It is 3. So it is the pair minus 6 comma minus 3 is divisible by 3. Minus 3 is 0, 0 is related with 3, 3 is related with 6, 6 is related with 9, 9 is related with 3, 9 is related with 0, 9 is related with minus 3, and so on. So you can find out also that is every element of a particular set is related with itself, but no element of one set is related with another set. Such sets are called equivalence class. So I hope you understand what is the meaning of equivalence class. Thank you very much. For any doubt, किसी भी सवाल के लिए आप इस पे पोस्ट करें, एंड अपना सवाल ज़रूर पूछें. आपके कमेंट का इंतज़ार रहेगा. धन्यवाद.